right, so we're going to calculate or estimate bond enthalpy of reaction from bond energy. The energy needed to break and energy released when a bond forms to connect that to an overall reaction. Now, this information, specifically the formula that I'm going to give you, is not on your pink sheet. I'm going to give you a formula and some steps. The formula is not on this, so you're going to need to be able to calculate these based upon your knowledge that when a bond is broken, it requires, and when a bond is formed, it releases. All right, let's get right down to it. So that's what we're doing. Here is our formula. All right, this is enthalpy of reaction. It's the sum of all the ones that you break plus the sum of all the ones that are formed. Remember, this would be positive, and this is going to be negative. And then when you combine them all, that'll tell you whether it's exo or endothermic. Here are the steps. All right, balanced equation. Draw the Lewis dot structure to really help you visualize what the bonds are and how many there are of them. And then sum up the bonds and broken or made. All right, so here's our example. We're going to combust some propane, and we want to know the enthalpy of the reaction. All right, here we go. So the first thing I'm going to do is draw a Lewis structure. This is propane, so it's a nice 3-carbon chain. All right, and then that's the rest of them. All right, now from this Lewis structure, what you can do is it's going to help you figure out what kind of bonds you have and how many of them are. Like in this one, I've got 2 types of bonds, carbon-hydrogen and carbon-oxygen. Here are their bond energies. These values, they came from a text, they'd be given to you. All right? And that's the rest of them. All right? And the next thing to do would be to do like this long math equation, you can see it right there, as to figure out the overall enthalpy change. Now this side, the breaking of the bonds is going to be positive, and the formation, everything over to the right, these 2 values are going to be negative. All right, when I plug them into the equation, because I am forming these bonds. The value, when you look up these values or the ones that they've given you, you'd have to know how to put the sign in correctly. All right, so how many of these bonds do I have? I've got 2 of them. So that's 2 times 347. How many hydrogen carbons? There's 8. Now, you use the coefficient. There's only 1, so I don't multiply this by anything. Okay? There's only 1 of these. However, there's 5 oxygen molecules, so I'd multiply that factor by 5. All right? And now here, I'm going to multiply this by 2 and then multiply it by 3. And remember, that's going to be negative because I'm forming those bonds. And similarly with water, 4 times however many, that's 2. And I forgot my negative. Ooh. This should be negative. All right? Now, if you wanted, you could also just turn this into negative if you wanted to. All right? I didn't do that. So when I multiply that out, I get these factors, or multiples, or products. No, sorry, products is the word I'm looking through. I add them all up, and then I get this. All right? I have, so that's what it is. And then I looked this up on Google, and here's what I found it to be. So negative 220 kilojoules per mole, negative inverse mole, a reciprocal mole. So there you go. So it's really close to it. So remember, we're estimating the heat enthalpy of reaction. That's how you would do it. All right, let me know if this helps. Bye.